Hey everyone, this is Matt with Learn Everything About Design, and in today's video we're kicking off a new three-part series talking about 3D scanning and design off that scan data. We're going to be looking at an RC truck part. Now specifically the gearbox or transmission cover. We're going to be taking that part, 3D scanning it, we're going to design a part based off of that scan data, we'll 3D print it, which is this part here, and we'll put it back on the truck. So throughout this three-part series, we'll go through everything from the setup, what we need to do to prepare the part to be 3D scanned, tips along the way about how to capture that data the best that we possibly can. We'll go into processing that data in our second video, and in the third video, we'll move into Fusion and we'll design our part with that scan data in mind, finally 3D printing this and bringing it back and putting it on the truck. So this first video is going to be the basis of that, which is how to prep and capture that scan data. Now remember that we are a Revopoint affiliate. We'll be using the Mini2 scanner in this series. And if you're looking to purchase a Mini2 scanner, make sure that you go to the affiliate link in our description and use the code LEADREVO100 and that'll get you $100 off. So without further ado, let's hop into this first video and let's talk about what we're going to be doing specifically today. We'll talk about a couple of different topics. We'll think about things like, do we even need to scan? Can we just measure the part that we're trying to recreate? Can we go directly from scan to 3D print? Or do we actually need to do something in 3D? Are we changing the design? Are we replacing a broken part? What does the entire process look like? Okay, so the next part of this we need to figure out is, do we actually need to scan? Now, a lot of times people think that a 3D scanner is something like a magic wand. You can just wave it over your part and boom, you have a 3D model. That is not at all the case. It takes a lot of time to prepare for scanning, to scan, to process the scan, and then move into 3D. So before you ever get started on a project, think if you even need to create a scan. Now, I've done a lot of parts over the years just by measuring, even fairly complex stuff. So look at the part that you're trying to create, figure out whether it even needs it. Now, the part that we're going to be doing is this gearbox cover for this RC car. Now, this is a perfect example of where a scanner is needed. You could potentially get something that works without a scanner, but the shape and the details on this really help us out if we create a detailed 3D scan. There's a cover that pops off here and we've got a couple of screw holes. So there are things that we will want to measure, but for the most part, the rest of it, a scan is going to be very beneficial. With other parts like small links, for example, sometimes the details are going to be too small to pick up with the scanner. These are little links for things like servos to control the steering, and there are gears or little teeth on the inside. That's just not going to be able to be picked up very well by the scanner, because by the time we spray scan spray on this, or if it happens to be a color that we can scan easily, then we just aren't going to get the detail in there because it's inside of a hole, you're going to have shadows, and it's just not something we can replicate easily. So what we would need to do is figure out a way to gather that information to measure it, and the rest of the geometry is pretty easy to measure. So even if you're scanning something and you are going to be using just as a rough guide, you're still going to want to measure things like bolt hole locations. So for example, for this part, there's a counter bore on the back side, and we're looking at, let's see, it looks like about 0.291. So that's probably somewhere around 7.5 millimeters. That information is going to be more important for us to gather using things like calipers or using different measurement tools that we have available to us. When we're getting a 3D scan, remember we've got pretty high accuracy and tolerance values using the Mini2. But that doesn't mean that we want to rely on that for those detailed informations. So with our part, again, we're going to be scanning this gearbox, perfect example for it, or the gearbox cover, I should say. But other things on the chassis, like the bumper bar, while we could scan it, it probably is easier to just measure if we're trying to recreate something like this. It's not a critical feature. We would want to measure the hole locations and the distances between them. But for the most part, that's something that we probably don't even need to bother scanning. Same thing with some of the links. The suspension links are fairly flat. We can get some rough measurements off of them and then we can build them in 3D. So keep that in mind. Remember that it's not a magic wand. It's not going to magically let you create a 3D object that you can just print. While we can go from scan to print, for a thin wall part like this, we have to go to CAD. So you need to take the time to clean this if needed, to prepare it with scan spray, to actually do a lot of scans, get extra data more than you think you need, process that scan data, then move into 3D before we ever get to a 3D print. After you decide if you want to scan something or not, the next part of that process is the prep. So if you decide not to scan something complex, what are your options? And if you do decide to scan something, what do we need to do next? Well, I have made a lot of parts by using a tried and true method of just tracing it on paper. Now, for something like this transmission cover, it's going to be a little bit tricky, but we can get some basic measurements and we can get the outline of it by simply putting it on a piece of paper and tracing the outside shape, and then putting it into a traditional 2D scanner. Put it on a scanner, get it into the computer. Now, one thing that I always do with this is I would get a ruler and mark down some sort of grid or use engineering paper that you know the distance between edges. So that way you can get a scale reference, because sometimes when you scan things in, it's going to be too big or too small. If you do decide that you want to do a 3D scan, the next thing that we need to think about is going to be the prep of our part. Now, in this case, we have a black plastic part. Now, even though it's not shiny, it's got sort of a matte finish to it, this is not going to get picked up by the scanner very well. Now, some scanners, such as the Mini2 that have a blue light structure, will do a little bit better on shiny parts, but also keep in mind that blue light also has trouble with certain colors as well. So if you're capturing color data, you might have some trouble based on the fact that the blue light responds to those colors differently. But for our part, being that it is black plastic, we're going to have to prep this. Now, the prep part of the process can get pretty messy. And what I'm going to do is I'm going to pop this little cover out, and I'm actually going to use a piece of paper, and I'm going to be using, in this case, @Blime Scan Spray. Now, this is not a sponsor of the channel. This is just something that you can buy online. ASUB is another big brand that makes scanning spray, and there are a couple of things that you want to make sure you understand when you're doing this. Now, we've done a video in the past using the Morocco and the scan spray to do a fender on a car, but just a couple of quick points. Scan spray gives the part, in this case our black plastic part, a nice reflective surface, and I say reflective, but something that the scanner can actually bounce its shape of the lines onto and bounce back and measure that distance. If it's too shiny, then you're going to have problems, and if it's too dull, then sometimes you'll have problems as well. But for the most part, when you have a black plastic part, like something on the chassis of an RC car, you want to use a scan spray. Now, there are a pretty wide scale of ways that you can do this. Everything from doing it yourself with something like baby powder and isopropyl alcohol. I've heard people use things like athlete's foot spray or spray deodorant. Those might work just fine, but the problem is the cleanup. And the cleanup on this is messy as well. This is what's called a permanent spray. And it doesn't mean that you're painting the part, it just means that you have to wash it off. They also make different types that will actually go on and be on for a couple of hours, 2 to 4 hours generally, and give you enough time to scan the part. And then they will evaporate on their own, making cleanup a lot less of a mess. This stuff is going to be chalky and messy. And basically once we spray it, the carrier inside, the liquid, is going to evaporate, leaving the powder on the surface. So if you touch it and move it around, then you're going to have problems because you're going to be wiping that off. So when you go to prep your part, make sure that you know where you want to scan. And for us, I'm not going to be scanning the inside of this. I'm only going to be doing the outside because it's a consistent wall thickness. It's a molded plastic part. And I'm only going to be referencing the outside. The other benefit to that is the bottom is flat, which means that when we scan it, it's going to be very easy for us to just cut the bottom of the scan off and have a nice clean scan to work with. If we want to, we can then fill the bottom in and make this essentially a solid or a watertight volume, but we're not really going to do that for this part. So in order to prep this, you want to be in a well-ventilated area, especially if you're spraying something big. This stuff is pretty nasty, so you don't really want to sit around and breathe it in. For the @Blime stuff specifically, it comes with 2 different nozzles. There is a sort of cone spray nozzle, and then there's a flat spray nozzle. So if you're doing a large part like a car fender, you can use the flat spray and go back and forth. If you're using something like a small part here, you may want to swap out to the round nozzle. So I'm going to swap this out, give it a nice little shake. And all we really need to do is a very light coating. You don't want to coat it like you're painting something. It's not going to be like a primer or a final coat on a painted part. You just need to get the surface to be consistent. And that little blast is pretty much all it takes. Now, in this case, again, we want to be careful where we're touching it because it will smear it off. You'll be able to see some wet spots as it's beginning to dry. And once it's completely dry, then we're ready to scan. All right, while that's drying, I'm going to put it off to the side. It only takes a minute or two. And we need to talk about a couple of other topics when we're talking about 3D scanning. That's going to be how you're holding the part when you're scanning it. Are you moving the scanner around? Are we using a turntable? Do you need to use marker dots? Do you need to use a magic mat? What are all these things and when do you need to use them? Well, for the Mini 2, the scan area is relatively small because it's a detailed scanner. So for a part like this, there is no way we could use marker dots, partially because you need to have 4 to 5 marker dots in the frame at all times for the tracking to work. So that's something that's complicated and presents a problem when you're scanning smaller parts like these parts for the RC. Now, if we're scanning the entire chassis or if we're scanning the body of the RC truck, that's a case where we could use marker dots because there's plenty of area, we can get the scanner far enough away, and we can use those marker dots for capturing. Now, personally, I do not like to use marker dots on small objects, especially when we're using a scanner like the Mini 2 because it really just takes up so much area on the scan, and then we have to remove those and clean them up afterwards. And while the software does a pretty good job of it, it's not going to be as good of a surface as if we didn't have those marker dots. So I prefer to use feature tracking, or if possible, use something like a magic mat. So when you get a Mini 2 or really any scanner from Revopoint, you get a couple of different options. The first of which is something called a magic mat. Now, the magic mat is a black mat that has a bunch of these reflective dots already on it. This is great because you can set it down on a table. You can put a larger part on this, say a bike helmet or a wheel or something a little bit bigger than the part we're scanning. And then it uses these marker dots in space, and we can use that to track the object without having to put any on the object. Now, this is a bit big for what we're doing, but there are other options. So inside of the Mini 2 kit, the very back, we've got a couple of additional options. We've got the magic mat that comes with it, and inside of here, there's also some like gecko tape or gorilla tape. This is like a putty, it's not really a tape. You can use that to stick pieces down to things like the turntable, especially if you need it to sit upright. So if we were going to be scanning something like an A-arm, the A-arm is generally flat on the bottom, but if you've got something that's got some extra geometry to it, you can use this to stick it straight upright and you can get a good scan of the entire outside. There's also going to be marker dots. One thing that you'll find with marker dots is they can be pretty expensive. You generally don't want to use too many of these. So when you're doing a large scan, something like a transmission housing, if you're trying to do that with the Mini 2, it's going to be a lot of marker dots if you can't use feature scanning. The other thing it comes with is a mat that goes on top of the turntable. Now, Revopoint offers a couple of different turntables. You've got the 2-axis one that comes with the advanced kit. We've got the basic one that's inside of here. And this mat here can go directly on top of that. It spins around with it, and then you can have those marker dots and use marker tracking without putting them on the small object. This is great for certain size and types of objects, but remember that you need to have 4 or 5 of these dots in the frame at all times. That can be problematic, especially if your object is a little too big and it covers up too many of them. Or if it's really tall and the scanner needs to be up here, it's not going to be able to see those dots in frame. So these are great options, especially if you've got a certain size object that can fit on top of here and use those references. But it's generally made for things like figurines, so these little castings that come with the kits. This is a great option for feature tracking, but a lot of times with things like the brow or the hairline, it might lose its tracking. So using something like one of these mats that goes on a turntable is a great option. So for our part, we're going to be using a turntable and feature tracking. In most cases, feature tracking will get lost when you have a circular part like this, but because it's got those two separate sections and most of this can be seen in a single frame pretty easily, I think we'll be okay. If not, we can always add a little something that will count as an extra feature, and then we can remove it later in post-processing. Okay, so now that we've identified the part we're scanning, we've prepped it with scan spray, and we've decided that we're going to be using a turntable with feature tracking, we're ready to get set up. So when we're getting set up, a couple things we need. We'll need the cables, of course. So in the top of our kit, we'll pull out the USB-C cable, and then we'll find the cable for the turntable. The turntable is powered off of USB. There is an on-off switch, and there is a speed dial indicator for whether or not you want it to go extremely slow or fast. What I've found is the on-off switch is kind of hard to get to without moving the entire turntable. So I generally will set the speed first and then just simply plug it into the USB port whenever I want it to move. All right, so now that we have the cables, we need the turntable, the scanner itself, and our tripod. So setup is pretty easy. When we're talking about setting up the Mini 2, there is a quick release for the handle tripod. You can remove this. There is a flathead here and it'll have a 1/4 in the bottom of it, which is standard for cameras. But this is a much better option. You can hold on to this if you want to. For our purposes, we're going to be using it as a tripod because the part will be spinning on the turntable. We'll need to add the USB-C cable. Now this one does come with a small jack, so you want to make sure that you do screw it in. Because we're using it in a tripod mode, it probably won't have a problem, but if you are using it in handheld mode, it's a very good chance that the connection can get jogged a little bit or it can come loose, and that's going to mean that you just trashed your scan. So make sure that you do always screw that in. It's a little tricky to do by hand because the cable's in the way, but it can be done. And then this is going to go into a USB 3 on a laptop, PC, or if you want to, you can pair this with the Wi-Fi 6 over to a phone. I'm not going to be using the phone option because I just prefer to scan to the computer whenever possible. If I needed to do a wireless scan, I would use the Morocco and the near mode. It's just much easier because everything's all self-contained. But in this case, this will work fine. Now there are a couple of lights on the back of this. Once we plug it in and it is connected to RevoScan, it will have a green light next to the USB. So that is a good indicator that one, we're powered up, and two, we are connected. If it's not connected, that green light will be red, and you'll just need to double check to make sure that everything is connected on the computer side of things. So now that we're connected, the turntable itself is not a connected feature. And what I mean by that is RevoScan doesn't care or know if this thing is plugged in, powered up, or connected to the software. You will find that there are some turntable setups for some scanners that will allow you to key it. Revopoint does offer a very large turntable. This one, however, is just basic on-off. So there are a couple of things. We can make it go clockwise or counterclockwise, and then we have a speed dial. And I found that you don't really want this thing to go max speed, and all the way down is extremely slow. So somewhere in the middle is usually good enough. We'll need to make sure that it's close enough that the USB cable will reach, or you can have a USB extension. But as soon as we plug it in, we can kind of dial in the speed. And then get a good look at the software to see where the scanner is looking. We can see that we've got our depth camera and our exposure, and that'll give us a good idea as to where the turntable is. So I'm going to unplug it. I don't want it turning right now. Probably speed it up just a little bit. Then I'm going to get my part. Remember, I don't want to wipe any of that scan spray off, so I'm going to be very careful. Try to be very careful. Now, if you have to, you can always use something like a little Allen key and get it to pop off. Part of the problem is if you end up getting some of that scan spray off onto the turntable, it'll pick the turntable up as well, and we don't want that. But now that we've got it set up here, the next thing that we need to look at is how far away our object is. So on the right side of the screen, we've got our depth. We can see too far, too close. Because the Mini is really meant to be scanning things relatively close,
you probably have to get it closer than you think. So that looks like it's a little too close. We'll go back just a hair. And we want to be in that excellent range. So we look like we're skirting the edge there. Now we're in excellent, and that's probably a good spot. So make sure that you adjust it. And there we go. Now, once we have the distance set and everything is sort of in position, the next thing that we want to do is make sure that the exposure is right. Now, the exposure is extremely critical. If the exposure is too high, the scan is going to be junk. And if it's too low, you're not going to be picking up anything. So I'm going to turn auto off, and I am going to drag this dial up so we can kind of see what bad exposure looks like. So we can see all of that sort of red that's happening on the screen. And then if you look at the preview in the large portion of our window, we can really get an idea of what that red line is doing. So when we look at the scan, it's kind of missing pieces in this area, and that's right where the red is. You can also see down here, it's picking up the turntable. And if we look here, that is showing up as a small blue area. So what we want to do is find a balance between where the exposure just starts to turn red and where it has that nice consistent white color. So right here, this is perfect because the area in focus is all very gray, and then there's one spot that is going to show up as red. And part of the reason for that is because of the lights above us. So these lights are fairly bright, and the brightness actually does cause a problem. You'll find that, especially when using scan spray, the brighter lights with scan spray will oftentimes overexpose certain areas. And we can see that if I move my hand over, the red goes away. So it's all in terms of the ambient light. And this is one of the reasons why these scanners don't really work outdoors. Direct sunlight is going to kill your chance of getting anything good out of this. And it's not just a Revopoint Mini2 problem. It's most scanners on the market are going to have a problem with direct sunlight. So once we have the exposure set, you can use the auto option, and you can actually toggle and tweak this while it's scanning, but we're going to leave it set just like this. The next thing that we really need to do is check the rest of our settings. The bottom left camera is the RGB camera. We are not capturing color on this. There's really no point, especially since it's covered in scan spray. So I don't really care about that one. And then over on the right, we've got a couple of accuracy settings. We've got high, standard, and high speed, which is our 16 frames a second. Feature tracking or marker tracking, we're going to be using feature. And then the object type is general object. There's also a dark object option. Because we've scan sprayed this, we don't really need to worry about that. And then the stuff at the bottom here, we're not doing color scanning, but if we scroll down a bit, we've got our surface filtering ratio, and then we've got this thing called base removal. So enabling base removal will allow us to delete any unwanted flat surfaces. So this is perfect just in case it happens to pick up the top of the turntable. If we got some scan spray on it, it'll be able to automatically filter that out for us. Because this part is flat, this is a perfect option. If your part wasn't flat, then it probably won't work nearly as well. And then down here, there's some accessories. You can see that there's an app for the phone if you're scanning to your phone or controlling a turntable that's connected. Again, this one is a simple one. We plug it in and it starts spinning, but there are more advanced options, especially if you're doing a lot of this. So everything else looks good here. We don't have a handheld stabilizer device, and all the rest of those below are just information. So to begin our scan, we simply need to hit start, the play button, or we can hit the play button on the back of the scanner. Because we have it set up in tripod mode, I'm not going to be touching the scanner at all. If you were doing it in handheld mode, it's really not a big deal. So we're going to hit start. I'm going to let it capture a little bit, and then I want to plug in my turntable. So really what we're looking at on the screen is we're looking for that green. The green section means that's the data we're capturing. The blue is not quite enough points. So once we plug in the turntable, it's going to start spinning slowly. And because we're doing feature tracking, I'm starting right in the middle of that big revolved part, hoping that as it rotates around and picks up the other features, that it'll be able to maintain its tracking. As it gets back around to the other side, we might end up losing tracking. And what I would do in that case is I would put a couple of different pieces on the turntable itself, and those would help with tracking. But let's just see what it does. Now, one thing we'll notice is the areas where there are more scan spray, it's picking up great. The areas where there is less scan spray in the corners, it's not really getting that information very well. Now, one way that we can fix this is by kicking up the exposure. So again, what we can do is we can hit the exposure up to 3 while we're scanning. But keep in mind that if that begins to overexpose those highly coated areas, we could potentially have some problems. But you'll notice right now on the screen, we lost tracking. We've got an extra bit there in the center that's kind of floating around in space, but the higher exposure is actually helping us capture more. So what I think that we need to do is we need to pause or stop this, take a look at the data, and we could filter out some of that if we wanted to. Now, unfortunately, because we've gone so many frames ahead, probably just better to start over again. So what I'm gonna do is I'm gonna hit cancel, which is going to clear the scan, and it'll allow us to start another scan, but I need to add a couple of extra pieces on here that the scanner will pick up that can be used as tracking. So I'm just gonna take a couple of little pieces of paper, gonna ball them up so that they're unique shapes, and place them on the turntable on the outside of my part. I want to put them in a place where it will be able to pick them up. You can do this with clay, you can do this with other little objects. I could put the little figure that came with the kit on there if there's enough room. But again, it comes back down to how much coverage we had with the scan spray. I could also recoat this and add more. Just means that we're gonna have to do a little bit more cleanup. So I'm putting these around areas where we've got this big revolved center section, and that should help us pick up those extra details. We can also change our scanning distance. We can give ourselves a little bit more down here. What that'll allow us to do is capture more area, and we could raise this up and do a little bit more of a top down. Now, keep in mind, we want to be in the excellent range, but we can go further away or higher up. And as long as we're in the good range, we should be able to still pick up enough detail. I'm going to kick up the exposure amount. Let's go up to 4, see what that looks like. Maybe 5 is a bit high, so we'll stick with 4, and hopefully it can pick up those little pieces of paper. So we're going to try this again. I'm going to hit start. Gonna let it start to capture. And then we'll plug in the turntable. So this time, the hope or the idea is that those little pieces of paper are not gonna get in the way of what we're scanning, but they will give us enough that it'll help capture those unique features around the section where we're having trouble. So those can be also easily filtered out once we get it into the processing of the point clouds or the mesh, because they're free floating. They're not connected to the main body. So that way they're just very easy for us to pull out. So as it's going around, we just need to be mindful of what's being captured. Make sure it's not over or underexposed. You can see that with our current settings, it's actually catching a little bit of the table. That's why it's got that sort of piece that's floating around, that ring that's floating around the outside. Because I moved the scanner back so far, it's actually picking up a bit of the wood table. We could get around that by putting the magic mat down if we wanted to, but this looks like a much better result. It is capturing everything. So as it goes around, it has not lost its tracking yet because of those 3 little pieces of paper. So we're gonna let it keep going around. It's a good idea to capture more data than you expect to need. You don't wanna do a single scan and then go into the processing to realize that you've just missed something. So this looks pretty good, but it's far from perfect. So I'm gonna pause it and just take a quick look. So it looks like it's got a little bit of noise to it, and there is a double section over here. It's kind of hard to tell, but there's just like a little bit of a section over there. So I think what I'm gonna do is add a couple of extra pieces of paper. So let's go ahead and cancel this, which will delete all the scan data. And I'm gonna try to reposition this a little bit. Exposure value might be a little bit high. If this one doesn't work, I'm gonna recode it. I'm gonna add some more scan spray. So let's go ahead and I'm gonna take the exposure down 1, see what that looks like. Probably okay, but maybe a little bit low. I'm gonna leave it, yeah, we'll leave it at 3. And we'll start scanning. So this comes back to the original point where a 3D scanner is not a magic wand. Now, if you spend a lot of money on a laser scanner that's handheld, you're going to get probably better and more consistent results, of course, because you're spending thousands of dollars more for a different sort of structure of scanner. But if you take the time, you prep your parts, in this case, I could have prepped it a little bit better, and you use these tricks like little wads of paper around the turntable to help with that tracking, then you should be able to get decent results. And if you take the time to really get this part of the process down, that's when your results are gonna start to get a lot better. This part of the process cannot be ironed out later. If you get bad scan data, fixing it downstream in post is nearly impossible. So make sure that you take as many tries or attempts as you need to get the scan data. Go back, re-prep it, clean it if you have to, get more scans, because once you take it into the computer and start manipulating the points, you're really only getting further and further away from the original scan data. So if that is bad, it's just gonna get worse from there. We can already see that the results are looking quite a bit better. The scanner being lower is certainly helping. There is a bit more that we can do, so we're gonna do a couple of different elevation scans. So we'll do one lower, we'll do one higher, and then if we need to, we can combine those. So one thing I'm really starting to notice is those areas in the fillets in the corners, they're just not getting picked up. The exposure has to be way too high to get that. And what that tells me is that I really just need to put some more scan spray on here. So that's what we're gonna do. I'm gonna go ahead and pause this. Just take a quick look. I mean, this is certainly a much better result, but it can still be better. So let's do that. We'll take this. Now, I definitely put way too much on this side. If that happens, that is going to affect the scan as well. So it is a good idea to try to clean that off. If you have a rag or a paper towel, let's see, then now is the time to fix it. I'm gonna go ahead and just wipe it. Because it is just a powder, it comes off relatively easy. And we'll just do it a bit lighter. All right, so we're gonna let that dry, and then once we have it coated a bit better, we'll see what the scan looks like. All right, so it's pretty much done. The side I had to wipe off is a little wet still, but we can give that a shot. I want to make sure that all these little markers are far away. And we also want to make sure that we just clear out the old scan data. So we're going to hit cancel. And then now that we've got a bit more scan spray, we can get the exposure a little bit lower. So let's try 2. That looks quite a bit better already. So I'm gonna let it start capturing that. Probably a bit too soon for that one side since it's a little wet, but let's give it a shot. Scan's already looking a whole lot better. We'll definitely want to do a second scan looking a bit more down from the top, even though it's not really required that we get the detail in that section because it's just a piece that pushes in. But this scan data is already looking quite a lot better on the screen. So, this is really what comes down to the difference between prepping your part. A little bit of prep goes a long way, but making sure the part is clean, which we didn't do, making sure that it's coated evenly, which is a big thing because that exposure limit, there is an auto exposure that will allow it to go up and down, but for the most part, I like to set these manually. And as the scan's coming around, it looks like the paper pieces are doing their job and we're not missing anything. So it still has its correct alignment. And so far, so good. So I think we're going to call that one complete. Let me go ahead and pull the power on the turntable. And then we'll do a second scan a little bit higher up looking down. So we don't want to process it. We're going to do a new scan. And then make some adjustments here. So go a little bit further up, look down a bit more. So this is going to help us get the detail around the top. And then we'll do one that's a little bit lower potentially. All right, exposure still looks good. Still have some red areas, but as we rotate around, we'll be able to capture those. Paper's still tracking. So this top-down scan is going to give us data looking down into the root of that fillet, that rounded corner. Sometimes it's hard if you're at a steep angle to get that. So we want to make sure we take one up top. It's also going to give us the detail on the opening. There's a little like try feature there. So we want to make sure we try to capture that. And because it's sitting flat on a black surface, we have a pretty good idea where that plane is. When we are designing a part based off of this, that is going to potentially be very easy, but you never know until you get it into the computer and start playing around with it. But so far so good. Alignment looks good, speed of the turntable is good, and the data that we're getting back is good, except for one spot where I smudged it with my finger. It's not picking up around that outside, but I think we have enough information because it is a revolved feature, it's circular in nature, that it's okay if we're missing just a little bit there. Not ideal, but I don't think it's worth spraying it again. So that looks pretty good. One thing you can also do is you can pull the power on the turntable and let it just hang still for a frame before you pause it and complete it. And then we'll complete that and we'll do one more. One of the biggest things that happens when you first start scanning is you try to go way too fast. Now, when you see something on the screen that looks like it's coming in very nicely, it can be misleading because you don't really know until you take a little bit of a closer look at the scan data. So with something like this, I want to make sure that I take my time, get a couple of different distances and a couple of different angles. Even though one scan may potentially be all we need, it's better to capture more and then just trash it if you don't need it. So we'll go ahead and start all the same settings. Let it capture a few frames. We're up to 40 frames, and then I'll plug in the power to the turntable. We'll let it go around at least one full revolution, and then we should have enough data that we can do what we need to in the computer with it. All right, looks like we've got enough here. I'm gonna let it go around a bit more. Gonna pull the power and complete. What we see on the screen in the RevoScan software is a little bit behind reality because it does take time to capture everything. So you won't instantly see that change, but I think that we've got a pretty good selection here of complete data. You can do a quick review. You can see some artifacts kind of out in space. But overall, I think that looks pretty good. So we're gonna do a quick save. And now we can move on to doing the processing.
Okay, so now at the end of part 1 of our 3-part series, we've captured our scan data. Now, if you've had any trouble capturing your own scan data, if you're following along with one of your own parts, make sure that you repeat this process. Because once we get into RevoScan and begin manipulating the points and creating a mesh, we can undo and start that process over. Once we get into CAD and we make design changes or we make any problems for ourselves, we can always restart that process. But we cannot go back and recreate the scan data. So you have to make sure you take your time. This takes a little bit of practice to get right, and you will want to make sure that you do go in and spend the time to get good scan data before you move on to the next step. Now, if you have any questions along the way, please leave a comment. If you like this type of content and you want to see more scan content, please let us know in the comments as well. For the second episode, we're going to be moving into RevoScan 5 a bit deeper. We'll process everything that we captured here before we move into Fusion. So once again, if you have any questions, leave them below. And as always, thanks for watching. We'll see you in the next one.